Talking to my Okay, guys, I'm my mouse go. Today I'm start working for this lab after 8 or 9. Then till now it's 4 a.m. So today the lab we are going to do is actually design it. Today I post homework and do all of them. I'll get this weekend. Will be on 14, so you have to be prepared. And I do not think we need to talk about the lecture this week because the lecture actually very easy. I'll talk about it later actually. Okay, let me see. Today our lab is torque and pulley because this lab is very important. Let me open it again. So it's actually related to your real life. Actually, we can lift a car or a truck or even in a building from one place to another using this lab. But both of them has a limitation. I will explain to you during the class. So, our first part is torque and pulley. It's very actually force. Torque means the force in a circularly motion. When I talk about the force, then force is actually linearly moving, but torque is circularly moving. But we don't understand when it's 90 degree. That's why you don't understand. You don't have to worry about it. So this simulation are very first one is the balancing act. If you click on those link, then you'll find those. Okay, then balancing this one, I think that one will be good. So today our lab is force of the object, level, ruler. Ruler will be much more good. You have to click on the ruler. So our lab is very simple today. Oh, let me. So this is our equation. So this is in the middle. Let me okay, annotation. So from the torque, this is we think that the force is happening in the 90-degree angle. That's why it's tan theta equal to 1. So you don't need to worry about. And there is a ruler. This is ruler. And today I will talk about why everything, our brush or when we try to do anything or the crane, everything has longer arm. With the longer arm, why it's longer arm? Arm is longer, like why there is something when you see that there is nothing but force in a circular motion. Actually, we can lift uh, higher massive object using torque. How can we do it? I will explain to you. In the middle here, so if you put a mass here, let me that on. So if you put a mass like 20.5 right now, if we are using longer arm, see it balance out. So we can using longer arm, we can your simulation will be like that. You have to remove instead it will be like that. You have to remove that one. You have to really, click on ruler level. This is the level. So here you'll see that we are using this side is longer in the middle. This side is longer arm. This side has shorter arm. And we'll see that here I am balancing 20 kg here by 5 kg. and the distance from the center to this one is 0.5 meter. So it's very small, but the longer arm side is very small. So using less force because we know that weight is one kind of force. So force equal to mass times gravity. See, mass times gravity. So mass is 5 kg times the gravity is 9.8 for Earth. All of you know already in this class, 9.8. So the force will be like 5 times 9.8, it's almost 25. 5 Newton, force unit for force is Newton. So from here, so this side and this side supposed to be equal. So that side torque on the right hand side equal to torque on the left hand side. So what happens is that in the torque there is a distance times force and distance times force. Force. So F1, this is R actually, guys. This is either R, small letter R, or R, or R. Other way we write it. Oh, this is the R. We can write any way we want, R. And this is the G. Sorry, G. Small letter G. G. This is the G. So let me see. So to balance this side, the right hand side and left hand side will be longer arm side and shorter arm side. So the total torque will be equal to right hand side and left hand side. To balance it out, in the torque, we know that distance times, and but here distance is small, here is distance is long. So if this is multiplication, that's how the multiplication value is. To make it equal, they will balance each other. Might be one side is heavy but in the distance here you will see that 5 kg, 20 kg, how many times of 5 kg? 4 times. So you'll see that I am putting the mass in 0.5 meter. So the mass on the other side is what? 4 times more. To understand? 4 times more. So it's 0.5 times 4 is 2 meter. So it's 2 meter. It's in 2 meter. So this is the one I'm explaining to you much more. There is one side is this up. It's 20, 40 page. In one is 40, is there will be a 40 kg. Go to there. So this will be unknown mass. And from the distance, they are balanced. See? So from the distance, we have to calculate the unknown. So distance times force. The gravity on both sides is equal. So mass times the distance, 2 times 5. And this side is 1 times the length on the here is 1. And I don't know. It will be 10 kg. Do you understand? 10 kg, how can I find it? Because distance times, there will be G also gravity. So distance is 2 meter and mass is on other side is 1 meter and mass we don't know. So 1 times m equal to 1. If you multiply any value with the 1, then it will go. Otherwise, you can divide that one. No, I will show you. So 2 times 5 equal to what? 10. So other side is 10 and 1. If you divide 10 by 1, 10 divide or multiply anything with a 1, it will stay same. So the mass of the unknown D will be 1. That will be 1. Okay. So here, place, let me do the left. Correct. Let me write it down. Clear out the drawing. So what is happening? Oh, so what is happening is that we have to place 20 kg on, we have to need ruler level. 20 kg on 0.5, 0.5 and 5 kg. We have to balance right now. It is not balancing. It is not balancing. When they are in the level, they will be. That's why we'll put the level. It is not balancing. It is close to it. Putting to. Oh, yes. We are able to find. So, what is the unknown length? Visual length is 2. And percentage of error, you have to draw this diagram. You don't have to draw the ruler. So, you don't have to draw the level. Here will be red one. Yeah, one block and how much the mass, that's will be enough. The middle will be like that. And there will be, you have write a ruler with a line, that's it. And that's the one block, another block here. Then you just draw the system. The measure mass on the string is 5 kg that side, and string position on the balance. Position of the balance is what is it? And from the ruler, it's 2 meter. Till the mass of the stick. Oh, you don't have to do that because we are not doing the experiment here. So you don't have to do that one. I will delete that one later. Okay. Okay. Now, right now we have to start the lab again with that one, the 15 kg on 0.5 marks, and place any object like 10 kg on for ruler. 10 kg. Oh, that would be gonna be this 0.75. I will upload this off earlier on. So 0.75. So they are balanced. So their ratio will be equal. That's why the ratio means that the mass times distance. So what is the mass here? 10 kg. If it's in earlier it was 0.75, then it will be like this one. So this is the longer, shorter arm. This is the longer arm. In longer arm, you need less mass. So in a brush, that's why we are using longer arm, and like by giving one side higher mass, what is called lesser force, we can using longer arm, we can it will act as a force multiplier. But there is a happen is that if you increase the longer and longer arm, if the object will break, even you are using steel object, a very heavy steel, still it will break because it has some limitation. The object has limitation. It is act as a force multiplier. It is not actually the increasing the energy or from the conservation of energy. It is not actually changing the energy. Life easy. This kind of lab. So this kind of you have to and you have to measure different, change the different mass. That's all. And next lab you have to place 80 kg person. Okay. Okay. 80 kg person on 0.5 and 0.5 mark and 20 kg on the other side. And right now we have to balance any position where it make, oh, it's balanced. Right now it's balanced. Yeah. See, you don't have to write it. So this ruler, when you are drawing, you don't have to draw the ruler. Okay. So that's how you will submit the lab for first part. And you are seeing that the using the longer arm, you can increase the force. It will work as a force multiplier. That's how crane or mm, the other system actually work it this way. And even with the brush, we are using longer arm. Even the people who cut the grass actually use longer arm because of that. It will act as a force multiplier. Okay, that's it. And next one, oh, you have to measure the length from here. What is the length here? 2. So you have to write it, you have to draw this one without ruler. You have to draw this. And instead of 80 kg person, you will draw a block. That's it. And write the amount of mass here. 80 kg, that's a really 20 kg. And if percentage of euro, you don't need to write it. I'm just giving it because calculate mass, you don't have to do anything, the formula, so that you know. Oh, that's how number 4 will be 60 kg. Okay, it's got 60 kg. Here is a 60 kg. That person, that's 2 person. Okay, 60 kg person who is here. Um, and right now we are going to balance this up. We need ruler actually. 5 and it's half. Then it will be at 1. Now we are balanced. So you move the string. Move the string means that move that one person in the ruler, but it says that. No, don't worry about it. And when it's balanced 1.5 meter, the person in 1.5, let's see. It will be, I think, 10, let me see. 10 figure of it, 1.5. 10 is the percent. Which one is the answer? See, 20 kg balance the, oh, you can do with the kit. Okay, they're balanced right now. This is the answer actually. We have to draw with the rule without ruler. You have to draw this one. Instead of writing or drawing a person, you have to draw a, what is this called? You can take the screenshot and put it in the digital second lab, and you have to measure the distance. You need to draw like that, and you can measure the draw the lines like that way in the ruler, not very detailed. And the measure mass of the there is 20, which is unknown, and the position is 1.5. And calculator, we don't need this one actually. I will uh, delete that part. Okay. Mm, mm, delete. Oh, we don't know the stick mass. That's why. Okay. This is not happening. No. Mm, I'll upload this one actually. Sorry about it. I actually designed it today, this lab for you, because I know in the real life you need it actually. So this kind of, we can use that. We are using this kind of equipment a lot, but it has limitation that the strength of the material, like here is the ruler stick we are using here, the ruler. We don't need that. This strength of this what is called bamboo stick actually has a strength, or even it made out of steel, it still has limitation. That's why we use the next step, pulley. And pulley system actually order to the pulley. Okay. We have to, in here, let me explain to you. This is called um, uh, pulley actually increase also force multiplier, but we have to apply force, less amount of force per unit time, like force, but you have to pull longer using the longer. If there is a larger amount of pulley, I will explain to you later. Larger amount of pulley, with the time, you have to pull the longer length of the length of the rope. But what happens is that you will apply less amount of force per unit time. So you are working same, but what happens is that your work right now you have to apply less amount of force. Like you are working similar, but when you want to move a car, what is happening? You have to apply a lot of force at an instant time. But what happens if you per unit time you are applying less amount of force? Then it will make your life much more easy. Even though you are working same, but your life will be much more easy because you are applying less amount of force. How can I do it here? I'll explain to you. Here, we want to lift this 1 meter, suppose. See, just look, where is the rope? How much we lift? Here, we are lifting full diameter. Full diameter, the full compound, double compound. We can. Okay, guys. In the pulley system, this is called stationary pulley and double fix. This is called stationary pulley and this is called moving pulley, guys. In a moving pulley, we have to work less. For what is this called? For stationary pulley, we have to work higher, much more, because moving pulley actually what happens is that there is a tension on the rope. Let me draw it. Let me draw it here. Here, let me draw it. There is a tension force because of the weight or gravity. All object is going downward, but because of the tension on the rope, in the moving pulley, there is two upward force actually. You're pulling it upward. Do you understand? So there is two tension force. That's why you have to work less. If you increase the number of pulley, moving pulley, then the force will be the force you are applying actually lower and lower. That's why in using moving pulley is much more helpful. But stationary doesn't help us much because the force will be equal amount, but it is actually to rotate. This is its mechanism. But if we increase the number of pulley, what will happen? The tension force. Let me let them all of them here. There is a tension force on the rope. This represented by capital letter T. Capital letter T. This is tension force on the rope. Actually, equal amount of retention force actually pushing is upward. The weight. So even though you have, suppose you want to lift 1 meter, all the lift actually using pulley. So 1 meter, you have to lift 1 meter to, you have to, what is called, change the length of this side 1 meter and this side 1 meter. That's why there is two sides of the rope. So you have to pull twice. So there to, uh, to, to pull, you have to pull 1 meter, you have to actually, um, grab the rope grab the rope and try to pull the object. You have to uh, pull the rope 2 meter. You have to pull the rope 2 meter, because this each rope actually needs to pull 1 meter. If there is a four of them, okay, there is four pulley. Yeah, here you'll see the four pulley is like that. And right now there is how many uh, rope is attached to the mass? 102 pulley. That is how many rope is attached? 1, 2, 3, 4. So right now, if you want to pull, let me see, number of root compound. Now, and right now, if you want to pull, what will happen? To pull 1 meter, you have to pull almost 4 meter rope. That's why energy is conserved. But what happens is that you have to apply less amount of force, because tension force is working, that is pulling it upward. So how many? Let me explain it. One is here, another one is here, another one is here, upward, another one is here, upward. And this is two is stationary because they are fixed pulley, moving pulley. So for moving pulley, when you pull, then there is four tension is working on this moving pulley. So mechanical advantage will be 4, because there is 4 tension force is actually pulling it upward. To make it move 1 meter, pull how much? 4 meter, because there is 4. You have to change the distance of the 4 pulley. That's why mechanical advantage for 4 pulley will be 2 pulley will be 2 moving pulley. See, it's cheaper on the moving pulley, because other 2 actually is just rotate the pulley. That's it. Rotate the rope. That's it. It doesn't change the what is called. It doesn't moves and doesn't apply the tension. So they doesn't affect the what is called tension force. So mechanical advantage for 2 pulley will be 4. 2 moving pulley will be 4, because there is 4 of the rope is attached to the mass. Here is one, here is another, here is one, here is another. For 6 of them, that's why even in your home you are doing something. How many rope is attached to the moving? So when you are moving, there is the 4 of them. Okay, where is that? Okay. Triple is on. 1, 2, 3, 1, 2, 3. Triple means 3 moving, That's why. And 3 is stationary. Data doesn't count. That's why I'm using that one. But when you do it hands-on, it's much more easy. Even your lift, your crane, everything. Even the people who wants to lift, they use the pulley. Whoever fixed the home. So here we'll see that how many rope is attached to the mass, 100 kg. 1, 2, 3, 4, 5, 6, and 6 pulley. So mechanical advantages will be 6. Actually, there looks like this one is the real one, because you can design like this way, but it will take more space, and you have to attach the moving pulley to the mast, so it will become very like crane. It will take like 20, 30 pulley. There will be for lift. So it will take much more space. To decrease the space, they actually attach like this. Some other way also. So it looks like this way, but to understand us, to understand, we will draw when there is a one fixed pulley. So one is fixed pulley means here. One is fixed pulley, a single fixed pulley here. This is the one. If you in that case, to lift 1 meter, you have to what is the rope 1 meter for one fixed pulley. For second one is one fixed, one moving, one fixed, one moving, double fixed, or one single copper. So one fixed, one moving. It means when you are drawing, you have to draw like this: one fixed, one moving. See, one fixed. This one is fixed. This one is moving. You can draw this one. Two fixed, one moving. Two fixed means here you can attach another one, another moving, and here is the you can attach some or there. So this is like that. Let me draw it. Here is the another pulley. There will be two fixed, and here you attach somewhere in there. But you are not lifting. It's just support like that. So in that case, there is one moving, two fixed, and there is a rope around this moving. Fixed because it's fixed to is it is supported with the support of the wall, so it is not moving. These two pulley is not moving. The force you are applying is much more less because of the weight. So I will explain to it later, much later. So two like let me snap it. Two moving means here is two means two different pulley. One is moving, one is stationary. Or if this is moving, this is stationary. Because let me show you. This is here. See, this one is moving, but this one is not moving. So this one and this one are same, actually different way they write it. That's why I put two different solution. Four means actually four different. If they say four different pulley, means that two moving and two opposite, means two stationary. So there is two stationary, two is moving. And this is the one you have to draw. This one. Number 6 will be like this one. You have to draw this one. So what will be the mechanical advantages for 6 one? It will be 6. For 4, it will be means there is two fixed and two moving. So there will be two pulley. But how many tension is there? 1, 2, 3, 4. Even though you have to pull the rope much more higher length, but what happens is that the 4 times means that is 2 moving. If that's 6 times, then you have to pull the 6 time more the rope, but you have to apply less amount of force per unit time. Even though you have to work almost same. Yeah, one person can pull a very heavy object. Very heavy object means a ship. If we added hundreds of pulley and can lift a ship. So right now the force you need here 250 here just 63 Newton force. So it is very low force. Like if it's one pulley, see 400. If there is, I'm not able to show it. just check. Just single fixed force you need 100 kg. Oh, we cannot increase the increase mass here. For this one, we cannot increase that. Okay. See, it is for one moving, it is 500. For three moving, it's 100. So now mechanical advantage increase a lot. Means that you have to work much more less per unit time than earlier. Mechanical advantage for the moving tool, explain the mechanism in terms of reaction force. Because of the tension on the rope. You understand? The more moving pulley means more tension on the rope. Yes, more tension on the rope. So but we have to pull much more rope because more rope means the changing the distance. We have to pull each rope with the moving pulley twice. And this one is supposed to be to change the distance of 1 meter. This one, then total, if you want to lift 1 meter, this 100 kg object, then you have to change this one, this rope 1 meter, this rope 1 meter, this rope 1 meter, this 1 meter, this rope 1 meter, this rope 1 meter. So total will be 8 meter. So movable reaction effort to lift object does result the gain of energy? No, it doesn't gain the energy. Energy actually doesn't gain it, but it is force multiplier, not energy multiplier. Because energy cannot created or destroyed. It is the conservation of energy, but this is not true actually. In the nuclear reaction, we can do it actually. Einstein find it out. We will. But naturally, other than quantum mechanics, naturally this rule is true, very true actually. Ideal mechanical for a pulley system, like it is supposed to be 1/6, make it 1/6 by using 3 moving pulley. It make 1/6 of the force. So you to understand that the increase actually, it increases a lot of force actually. Like that. Lots of force actually. You need like output force. And input force you are giving, it's very less, but output force, the amount of force you are lifting is very high. Ideal mechanical advantage is like that 6, mechanical advantage is 6 times. So actual advantage will be much more less because there will be friction of the rope and it could be different alignment. So there is something. And so actually, but that one actually you can whatever you choose to write, the mass of you are giving the mass on that side and then giving the other side. You don't need this table actually. That one you need it. I will show you that after. No, I may count. For one system it will be like 1. There is no change. For 2 system I have 2, and 4 system it will be 4. 6 will be 6 because how many moving tool? And the mass, if we want to lift 100 gram, then how much mass we have to give here? 50. If you want to lift like 1,000, then it will be 500. Oh, it is no, there is one pulley, so there is no moving pulley, just one fixed. So that one is system of two different pulley, means one is moving, one is then it will 100, it will be 500, and this one will be 1/4 and 1,000. That one will be 250, and and it will be, let me see, 1/6. 1/6 is, let me use the calculator. Cal calculate 1000 thousand. Oh, what happened to the my calculator? Thousand by 6. So 160. So 1000 167. 67. Okay. So if you divide, then it will be 1, it will be 2, it will be 4, it will be 6. But what happen is that it will not be perfectly 1. It will be 1, but other don't. It will be 1, 1.2, 1.5, or 1.6 or 7, close to 2 most of the time. So what happen is that in real case, this is coming from the real case, how much lifting you are on side and other side. We will hang up other mass on this side, then we'll balance it out. Then this not always hold true. Like if you efficiency, if you divide this one by this one by this one, then you will find that this one will be 100, but this one will be not 100, close to 100, but not 190 or 95, or sometimes 100. Sometimes you get 100, not always. So real case is not hold true, but it cannot go beyond 100. This is the wrong thing, because there will be like some friction, or we could more than 60. I do think some people what happened is that other side, we think that they are supposed to be balanced. If they are not balanced, both sides, this side and this side, supposed to be like not moving. If they are not balanced, it means that they are not. It doesn't mean the same level. It means that they are in this. They are not moving. If they are falling, the one side is falling. Like they're supposed to be balanced. Like the earlier lab I show you. Not this one. Yeah. Well, uh, so they're level. They're supposed to be level. They are not level. They are not moving. If they are moving, like one side is falling, like let me see. One side is falling and another side is not go up and another side go down, then that case, if you measure the mass or something like that, this is the wrong thing. That's why sometimes they end up calculating higher than 100%, because they are not balanced, means they are not supposed to move. So what will happen, you have to find the mass on the right, uh, on, let me see. Yes, this, this if I do it on the lab, I'll show you the video. When they're balanced, then it will give you the proper result. Okay. Otherwise, you don't. I was doing it on hands-on lab, then it is giving me proper result. Okay. Thank you. Then you will. It's a different pulley, then equal number of moving. How many equal number of moving and equal number of, it might be other way around, but you have to choose that pulley, the equal number. They're supposed to be equal, but not. If odd number, then you have to choose. It is the number 5 will be what is called crane. The crane actually. Let me show you the. Let me show you the one of the lab I have done. crane. Mm. For my class, I'm just here. You see, it has longer arm and it has, let's see, what is the pulley? Mm, There is the pulley here. Why it's not this image? Okay, I go search on Google actually. Here's some pulley. There is C. Let me show you. Here is the pulley. See, here is the pulley. 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 So they actually using like 10, 12 pulley in the crane, and they also use longer arm to lift because they need longer arm to lift. I already explained the brush are bigger because of the longer arm, and that they also need the pulley. It is very important in your daily life. That's why I'm saying. These pulleys are, here is some pulley here. So if the crane is what is called much more efficient, they will what is this called? They will use more pulley. This is the capacity. Okay, thank you then. This is the one of the example. And stop share, stop recording. Thank you.